Hey everybody, my name is Zeb Wright, and I'm about to learn you some physics. Rotational inertia is something that we all use every day, but in various degrees. Today I'm going to give you some extreme cases on when rotational inertia is used, and then I'm going to be presenting you with how it is used and what three axes the human body rotates around. First, the human body rotates around three main axes. The first one is the longitudinal axis, which goes from the head to the feet. The second axis is called the transverse axis, which goes from side to side. And then the last axis is the medial axis, which goes front to back. Now that we know about the axes and which ones the human body rotates around, I'm going to explain what rotational inertia is. Rotational inertia can be defined as the difficulty it is to change the rotational velocity of an individual object around its given rotational axis. An example in this can be found in a pen. This particular pen starts in a very narrow end and then just gets bigger as it goes along. When I hold it down here, it's a lot more difficult to begin to rotate this pen. But when I hold it closer to the center or closer to the more massive end, it's a lot easier to rotate. Day 2. Using the definition that was brought up earlier, this means that it would have more rotational inertia when it's held at this end, because it would take more opposite force to stop the swinging pen than when it was held right here. When it's held right here, it'll be much easier to stop the pen when it's rotated, meaning it has less inertia when it's held closer to the massive end. Now that we understand the basics of rotational inertia and which axes the human body rotates around, let's get into some more fun physics. The first flip that I want to go over is the side flip, which looks like this. Let's slow that down a bit. Now the first thing to know about this flip is that it rotates around your medial axis, which is the axis that goes from your front to your back. Now, when I'm talking about flips, I like to imagine an axis as a rod that goes through the body. The next thing you should notice about this flip is that at the beginning of it, my body is all the way outstretched. This means that my rotational inertia is really high. The next step of the flip is the tuck. This is about halfway through the flip, right after you leave the ground. In the tuck position, my knees come to my chest, and my chest goes as close to my knees as possible. This decreases my rotational inertia. So why would I want to decrease my rotational inertia in a flip? Well, this is the reason. When you decrease your rotational inertia, it increases the rate of spin, or the rate that you can get up to speed. You'll notice that my tuck isn't very tight. You notice I barely bring my knees up to my chest. And the reason is because I don't need to rotate that fast. If I was doing a side flip on the ground, I would need to rotate fast because I would come into the contact with ground soon. There you have an explanation of rotational inertia in a side flip. Now let's go on to a more common flip, the back flip. The more common back flip is a flip that rotates around the transverse axis, which is the axis that goes through your body from one arm to another. It has many of the same principles as the side flip. The first one being, when he jumps, his body is all the way extended, increasing his rotational inertia. He then brings his body into a very tight tuck, decreasing his rotational inertia and increasing his rate of spin. So to sum things up, there's many different types of flips that people do, and they all mostly rotate around these three axes: the longitudinal axis, the medial axis, and the transverse axis. During the flip that the person is doing, when they tuck, that decreases the rotational inertia, which increases their rate of spin. In other words, to make a human being spin faster, you want to bring all the mass that is outside of the axis and bring it as close to the axis as possible. And this is how many gymnasts are able to do 2 or 3 flips before they hit the ground, the spring floor, or the trampoline. My name is Zeb Wright, and as always, hope you learned something on how the world works.